ICU ward full of COVID patients. So for example, this person is infected with coronavirus and has recently been admitted into a hospital. Now, obviously know that main symptoms of coronavirus is coughing, and along with coughing, this person is also vomiting. And nurse and other medical professionals handling this patient will have to actively deal with this patient, not only injecting various kinds of drugs, administering medicines, as well as feeding him. So what healthcare workers need is a gear that requires far fewer interaction points, because every time a nurse comes into contact with this person, she could be brushing up against the viruses. So we need to cut all physical as well as aerial contact with the infected person. So we need an active layering to protect all these individuals. And that is known as personal protective equipment or a biosuit. Now, it is important to mention here that personal protective equipment are just not to deal with viral infections. They are also used against chemical agents, nuclear agents, as well as to firefight. But here we shall keep our discussion limited to a biosuit. Now, first and foremost, a biosuit should be leak proof, which means that no material, not even air, can enter inside this biosuit, as well as there should be no exit point from inside as well, because the person coming from outside, like a medical professional, might carry some other infection which will be detrimental to the patient's health as well. So you need to cut all contacts from inside this suit to outside. So that's why a leak-proof suit and a material is needed. So for that, you need 3 ingredients. Now first is that material should be such which is non-permeable. And secondly, since a lot of stitching is used while making clothes to fit a person's body, a lot of sealing is used. And now the sealant should be long lasting and adhesive enough. An important point to highlight over here is that there should be an overpressure mechanism in the biosuit itself. Now what is this overpressure mechanism? Now although we know that we might make a biosuit which has a strong material and totally compact sealing, but still the probability or a possibility of leakage cannot be avoided. Now what they do is that they are designed to maintain a positive pressure inside the biosuit to prevent contamination to the wearer, even if the suit leaks or fails. So the higher pressure of air inside the suit will prevent the air from outside into entering this biosuit, and hence will provide a double layer safety mechanism. Now this is not the only mechanism which an ideal biosuit should have. Now apart from this, it should also have respirator. Now as you know that coming into close contact with the COVID patient means that you are inhaling an infected air, especially when you are dealing with the patient on a very close distance, and which means that you need air which is totally purified and it is independent of the air of the room in which the medical professional is entering, and that is why you need an independent respirator with filtration system. So these are the 2 common traits which an ideal biosuit should have. But apart from this, the specific Indian climate, which is both hot and humid, requires us to have a cooling system as well, because you know that these medical professionals deal with patients over a long period of time. For example, you might be reading in newspaper that doctors on emergency duty are catering to these patients for as long as 36 to 48 hours in continuation. And the material which is used in these biosuits increases the temperature inside these biosuits because they prevent the contact from outside, and hence an internal cooling system is also needed. So these are the 3 things which an ideal biosuit should have. Not to mention that the biosuit being used in India have these. But an important development has come from DRDO, which will immensely help in the production of these biosuits in the country. Now, what DRDO has done, that it has prepared a special sealant as an alternative to seam sealing tape based on the sealant used in the submarine application. Which means that earlier, the Indian companies used to seal the biosuits with the same material which was used in submarines. But now DRDO has developed another sealant. And what DRDO is doing is that it has transferred this technology to private firms which can now use this to develop these biosuits, which will go a long way in ramping up the production of these biosuits in India itself. Let's now move on to the infrared thermometers. Now you must have read in the newspaper and seen a lot of images where the passengers arriving from foreign countries have been screened on the airport with the help of infrared thermometers, as can be seen in this image. Now before going into the principle of this thermometer, let's first understand what infrared itself means. Now infrared radiation is just one type of radiation that exists within the electromagnetic spectrum. Now this is the complete electromagnetic spectrum, out of which you can see that visible spectrum lies here. Now this is the order of reducing energy, whereas this is the order of increasing energy or frequency. So you can say that infrared emissions have lesser frequency than visible light as well as lesser energy. Also, the wavelength of IR rays is longer than that of visible spectrum. But now the question arises that how this infrared radiations help us in measuring the temperature of a body. Now for that, you'll have to focus on this image over here. If you are exposed to even class 9th basic science, you must be knowing that all matters emit energy in the form of IR or heat. Now if there is a temperature difference between the objects, including the surrounding environment, then this gradient can be measured and used. So for example, if there is a heat source, for example, a person with a higher temperature, the characteristic spectrum of IR radiation from that person can be focused on a detector which is known as thermophile with the help of a lens which is placed right here. Now you might ask that how this heat can be focused. Now you should not forget that after all IR is just a part of electromagnetic radiation. And just like visible light can be focused with the help of a lens in front of a source which is emitting the parallel rays to its focal point, infrared can also similarly be focused. Now this thermophile is important here because after absorbing this IR radiation, it converts this IR radiation into the form of heat. And this heat is finally felt by a detector. Now this is a special detector which converts this heat into electricity. The higher the heat, the higher the electric current inside that circuit. And the internal mechanism of this thermometer is designed to detect that electricity, and it is calibrated in such a way that the human range of temperatures can be easily translated from that electricity into the final temperature, and hence within the fraction of seconds it displays a temperature. Now it is redundant to mention that why infrared thermometers are being used, for the simple reason because it obviates the necessity of a contact between the person and the person who is taking the measurement. It is fast, accurate, and it can also be used to remotely monitor the patients. The Naval Dockyard Mumbai has designed and developed its own handheld infrared-based temperature sensor for screening at its entry gate. Now it is significant because an average influx of this dockyard is around 20,000 personals every day, and you can't just screen people in such large amounts by employing personals with one infrared thermometer each. And for that you need a system of mass screening which uses something like this. So I hope by this discussion it is clear to you that what are personal protective equipments and what are the essential things which they should contain, what are infrared radiations, and what is the principle